Hello viewers, I hope all of you are fine. Today I want to discuss about the dipole and the electric field at a point P due to the dipole. But before this, we already discussed in our previous lecture that what is basically electric field, how we can represent electric field lines, what is electric field strength, and what are the characteristics of electric field lines. Now let's discuss what is basically the electric field at a point P due to the dipole. But what is basically a dipole? Dipole is basically whenever two charges of equal magnitude and opposite signs are separated at a distance d apart from each other, then they make a dipole. Dipole moment is basically represented by P, which is equal to QD. For example, the dipole moment of NaCl molecule is equal to 3.7 constant power minus 29 coulomb into meter. This coulomb into meter is basically due to the P is equal to QD. So this is the unit of dipole moment. Now dipole moment P is equal to QD, and it is the combination of positive and negative charges of equal magnitude and opposite sign. The dipole moment is always from negative towards positive charge. Now let's calculate the electric field due to this dipole. Now in order to calculate the electric field due to this dipole, take a dipole which are separated at a distance d apart from each other. Now the distance of these two charges from point P is basically equal to r, and the point P is taken along x-axis. From central point, the distance becomes half of d by 2. Similarly, this distance also becomes half of d by 2. Now in order to find out the total electric field at this point due to these two charges, then we know that at a point P the resultant electric field due to these two charges is basically the sum of the electric field due to the positive charge and negative charge. We know that the magnitude of the electric field of these two charges are equal in magnitude, so that's why at a point P the electric field due to these two charges is just that of a point charge. If we just talk about the magnitude of the electric field at a point P due to these two charges, now we know that the electric field due to a point charge at a point P is equal to kq by x square. Here we can take that distance r, so you can also take here that distance as r square. So this distance is basically r square. This is the electric field of a point charge at this point. Now from this figure we already know that in this triangle or in this triangle, r square from Pythagoras theorem is equal to x square plus d by 2 square. So r square is equal to x square plus d by 2 square. So r become x square plus d by 2 square whole square root r1 by 2. We can replace here this r square term by x square plus d by 2 square. So by replacing this term, this equation becomes x square plus d by 2 whole square. Now let's come towards figure. The electric field at a point P due to the positive charge has two components. One is the y component and other one is the x component. Similarly, the electric field due to the negative charge has also two components. One is the x component and other one is the y component. You people already see very clear that the y components of these two electric fields basically cancel out each other because both vectors are in opposite directions. So therefore the contribution due to the y component is equal to 0 because these two components cancel out each other. So it means that we are only interested in x components because the x component of these two electric fields are sum up or reinforce each other. So that's why we can add the x component of the electric field at a point P due to these two charges, which is basically E plus x and E minus x. Now we already know that Ex is equal to E cos theta. Both fields are equal in magnitude, so therefore E cos theta plus E cos theta is equal to 2E cos theta. But from this triangle we already know that cos theta is equal to base by hypotenuse, and base is d by 2 while hypotenuse is r. So d by 2r is equal to cos theta. But again this r can be replaced by x square plus d by 2 whole square and whole 1 by 2. So putting values in this equation, the value of cos theta is basically d by 2r and the value of E in this equation is equal to 1 by 4 pi epsilon naught Q by x square plus d by 2 whole square. So by putting the value of E and cos theta in this equation becomes like this, replacing cos theta by d by 2r and r by x square plus d by 2 whole square and whole 1 by 2. So this equation becomes like this. Now cancel out 2 with 2, q multiplied by d is equal to qd, and here the power is 1 and here the power is 1 by 2, so 1 plus 1 by 2 becomes 3 by 2. So this is the final equation for us, but again we already in start of this lecture we learned that the dipole moment P is equal to qd. So therefore replacing qd by P, so this is becomes an equation number 1. Now we already suppose here that the distance x between point P and the dipole x is very larger compared to the separation between the dipole. So the distance x is very larger compared to the separation between dipole, which is basically d. So in this case, whenever the distance x become very larger compared to the separation between the dipole, we can use the binomial theorem or binomial expansion. So that's why by setting this equation to the binomial expansion, we can move this term upward to the denominator, so this power becomes negative like this. Now expanding this term with the help of binomial theorem, we can get 1 plus nx plus n into n minus 1 divided by 2 factorial and so on. But all of these terms are cancelled out, which include square and again square and power 4, power 3, power 4 and so on. Why these terms are cancelled out? Because whenever in the denominator the terms become square, it decreases more and more, and we already suppose here that x must be very larger, which cannot be reduced. So therefore these terms are cancelled out, only this term left, which is basically the final relation for the electric field at a point P due to the dipole. Now what is basically the consequences or the resultant conclusion of this equation? This is basically the electric field at a point P due to the dipole. This relation shows us that the electric field due to dipole varies as a 1 over x square x cube or as a 1 over r cube, which means that the electric field due to the dipole varies more rapidly compared to the electric field due to the point charge, because in case of point charge the electric field variation is as a 1 over r square, while in case of our dipole it varies as a 1 over r cube. So the field variation in case of dipole is more rapid compared to the field variation in case of the point charge. Similarly, we can also investigate the electric field of quadrupole, but that is more complex case compared to this one. Here we consider a two-dimensional splitting of electric field component, and we summarize and conclude the electric field at a point P due to this dipole. So we can also find out the electric field due to quadrupole, which may be our next lecture or an upcoming lecture we can explain that. So thanks for your time. If you like this topic and understand this topic, then please kindly subscribe my channel. Thanks for your time.